Hi, this is Walter Stone, and this is part 2 of Lesson 3 of Unit 9 on quadratic functions. So we just want to remind ourselves how we, given a function f of x equals ax squared plus bx plus c, we found the x-intercepts by letting f of x equal to 0, which means we can use the quadratic formula to find these x-intercepts. The y-intercept comes from letting x equal 0 and evaluating f at 0. And the vertex comes from evaluating the function at the opposite of b over 2a. Okay, so we've been working with those sorts of ideas. Okay, so what you actually want to do is pause your video and do the try this problem on page 2, and then come back and check your work. So here, if you let f of x equal 0, and you factored, this is factorable, so it's easy to factor this into x minus 5 times x minus 3. So we get 3, 0, and 5, 0 as our x-intercepts. Our y-intercept is when x is 0, f of 0 is 15, so 0, 15 is the y-intercept. And when we take the opposite of b over 2a, that's the opposite of negative 8 over 2 times 1, and that actually is positive 4. And when we evaluate f at 4, we have 16 minus 8 times 4, which is negative 32, plus 15, and we get 4, negative 1. So we can, what you should have is some graph paper, and you can graph the parabola and see what it looks like. And we can also check this problem using Desmos. So when we're working with x squared minus 8x plus 15, our a value is 1, our b value is negative 8, so we can adjust that to be negative 8, and our c value is 15, so we can adjust that to be 15. So we see that 3, 0, and 5, 0 are our x-intercepts. Our y-intercept is 15, 0, 15, and we do get a vertex of 4, negative 1. So making a quick graph on Desmos using the quadratic function and changing the parameters to what we have in the function allows us to check our work and our graph. So now we want to concentrate our work on graphing quadratic functions. And in example 2, we want to find the x-intercepts, the y-intercept, and the vertex of f of x equals x squared minus 6x plus 4. Then we want to graph f. So the x-intercepts, f of x equals 0, so we can set x squared minus 6x plus 4 equal to 0. And there are no factors of 4 that add up to negative 6, so I have to use the quadratic formula. So I took the opposite of negative 6, the opposite of b, plus or minus the square root of b squared is negative 6 squared, minus 4 times a times c, that will be minus 4 times 1 times 4, all over 2 times a, which will be 2 times 1. And we get 6 plus or minus the square root of 20 all over 2. And the square root of 20 simplifies to the square root of 4 times 5. So that's going to be 2 root 5. And what we can do is simplify by dividing 6 and 2 root 5 by 2. So we get 3 plus or minus root 5. And this is an irrational, we have two irrational x-intercepts. And what I did was I took out a calculator and I looked at the values of 3 plus root 5 and 3 minus root 5 and just rounded to the tenths. So approximately the x-intercepts are 0.80 and 5.20. And the y-intercept, if I take f at 0, we get 4. So 0, 4 will be the y-intercept. And the vertex will come from taking the opposite of b over 2a. So we'll take the opposite of negative 6 over 2 times 1. and that'll be positive 6 over 2, which is 3. And the y value of the vertex will come by taking f at 3. So we have to take 3 squared minus 6 times 3 plus 4. And we get 9 minus 18, which is negative 9, plus 4 is negative 5. So that should be a negative 5 there. 3, negative 5 is the vertex. Okay? So if we make x equal to a equal to 1, b equal to negative 6, and c equal to positive 4, we can see that we have x-intercepts of about 0.8 and 5.2, and we have 3, negative 5 as our vertex, and 0, 4 as our y-intercept. Okay, so you probably are graphing these on graph paper, and we're here with Desmos looking at our work and making sure everything looks correct. So now what you want to do is do the try this problem, pause the video, find the x-intercepts, the y-intercept, and the vertex, and then sketch a graph of f, and either use Desmos or your graphing calculator to check your work. Okay, we're back, and this is my work for this problem. I use the quadratic formula again to find the x-intercepts, and I have x-intercepts that are approximately negative 3.2 and 1.2. F of 0 gives us negative 4, and taking the opposite of b over 2a, that'll be the opposite of 2 over 2, which is negative 1, and f at negative 1 gives us negative 5. So I'm getting a vertex of negative 1, negative 5. If we go and change b to 2 and c to 4, we have that well, actually it should be negative b is positive 2, c is negative 4. Okay, just to make sure everything's okay. So we see that negative 3.2 and 1.2 are approximately give us the x-intercepts. 0, negative 4 is our y-intercept, and negative 1, negative 5 is our vertex. Okay, so in this problem we've done a good job with looking for all the information we need with the intercepts and the vertex to graph this polynomial, graph this quadratic. Here in our last example, we want to graph g of x equals negative x squared plus 2x minus 2. For our x-intercepts, we see that negative x squared plus 2x minus 2 is equal to 0. And when we, there are no factors of 2 that add up to positive 2. So we go ahead and use the quadratic formula. And I approximated these two roots of the equation to be negative 2.7 and 0.7. So those will be our x-intercepts. I should see here that g of 0 is negative 2. So 0, negative 2 is our y-intercept. And the opposite of b over 2 times a will be the negative 2 over 2 times negative 1. That gives us a positive 1. And when we evaluate at 1, we get the opposite of 1 squared plus 2 times 1 minus 2. That's negative 1 plus 2 minus 2, which is negative 1. So 1, negative 1 should be our vertex. So here we have, we should have negative x squared. So what's going to happen is the parabola is going to face down. Then we have plus 2x minus 2. And so what we are, maybe I have the wrong numbers. I should have -1, I should have 2, and -2. So this is -x squared plus 2x minus 2. Okay, so Professor Stone's wrong sometimes. What should happen is instead of 4 plus 8 under the radical, we should have 4 minus 8. And 4 minus 8 is -4. So what that means is that there are, because we have -4 underneath the radical, there are no real numbers for the x-intercepts. So this parabola is correct. There are no x-intercepts because we have a negative underneath the radical symbol. We do get 1, -1 as our vertex, and when x is 0, -2 is our y-intercept. So it's really good to check, make sure things work out. So that -4 underneath the radical makes, we have to conclude that we don't have real x-intercepts in this case. So try the last problem, f of x equals -2x squared plus 4x minus 3. Find the intercepts in the vertex. Pause the video, come back, and check your work. Also, check your graph using your graphing calculator or Desmos. Okay, so when I was looking for the x-intercepts, if I've done this correctly, there were no factors of 6 that give me a difference of 4. So I used the quadratic formula, and we'll have 4 squared minus 4 times -2 times -3. That's going to give us a -24. So we'll have 16 minus 24, which is -8. So here again, we have a negative number underneath the radical symbol. That means that there are no x-intercepts. So it's going to be facing downward and have no x-intercepts. The y-intercept will be 0, 3. And the opposite of b over 2a is going to be the opposite of 4 over 2 times -2. And that's -4 over -4, which is +1. And when x is 1, we'll have -2 times 1 squared plus 4 times 1 minus 3. So that'll be -2 plus 4, which is 2, and 2 minus 3 is -1. So the vertex will be 1, -1. So in this last problem, a is -2, b is 4, and c is -3. So we do have a vertex of 1, -1, and a y-intercept of -3, and no x-intercepts. Okay? So this is our lesson on graphing quadratic functions, and in class we'll be working with using quadratic functions to model situations and solving problems. So you'll also have practice with your online homework. So best wishes as you work on these assignments, and we will see you in class.